This is our lesson on 11.5, factoring by greatest common factor. First of all, let's start off with the definition. What is a factor? Well, a factor is a product of numbers and variables. For example, what are the factors of the product 6x squared y, x minus 2, 2x minus 5? Well, we look at anything that's multiplied. The first thing that's multiplied is the 6, so 6 is a factor. X squared is also multiplied, and y is multiplied. Now, when we look at these binomials, we have x minus 2 as an entire factor multiplied to the 6x squared y. So x minus 2, without breaking it up, is a factor. And 2x minus 5, without breaking it up, is a factor. Now, what we're going to do with these factors is we're going to basically break down and see what the greatest common factor is between two terms. Before we start with some variables, we're going to start with numbers. We have two methods of doing this. Method 1, we're going to use prime factorization. We're going to compare 36 and 54. Now, when we make prime factorizations, we make factor trees. You may remember doing these back in a previous grade. So 36. You can break 36 down to 6 times 6. Now, there are other ways you can break 36 down. At the end, you will get the same prime factors, like you can take it to be 9 and 4. But I'm going to keep going with 6 and 6. I get 3 times 2, and both of those are prime numbers. So I'm going to circle them when I get to my prime numbers. And the other 6 is also 3 times 2. Now, since I have no more numbers to break down, this is as far as I'm going to go with 36. I'm going to start them in numerical order, but I have 3 times 2 times 3 times 2. So 2, 2, 3, and 3. Now, next, if I go to 54, once again, there are multiple ways that we can break 54 down. I'm going to take it 9 and 6. So 9 is not a prime number. We can take it down to 3 times 3, and those are our prime numbers for 9. 6, once again, 2 times 3, and we're down to the prime numbers. So 54 is 2 times 3 times 3 times 3. No matter how you started with 54, you should end up with the same exact prime factorization. The next thing we're going to do is we're going to find the shared prime factors between both of these numbers. So I'm going to find what's in common. I notice that they have a 2 in common, and they have 2 3s in common. So we have a 2 in common and 2 3s in common. Number 3 says multiply the factors together that were in common to get the GCF, or greatest common factor. So 2 times 3 times 3 gives me a total of 18, which means 18 is the largest number that can be factored out of both 36 and 54. Okay, let's do the same thing and put some variables in there. So I'm starting with 8x squared y and 24x cubed y. Starting with my numbers, with 8, I can break this down as 2 times 4. 2 is a prime number, so I'm going to stop there, but 4 can continue with 2 times 2. So there's my prime numbers for 8. My variables, I'm going to break down to how many there are. So x squared means I have 2 x's. And my y, I only have 1. Next, moving on to my 24. 24 can be broken down to 8 times 3. 3 is prime, but 8 is not. 2 times 4. 2 is prime, but I can keep taking 4 down as 2 times 2. And now I'm complete with 24. X cubed means x times x times x. And y, once again, just 1. Now, the pieces that I circled is going to be my prime factors. 2 times 2 times 2 times x times y. 24 x cubed y, 2 times 2 times 2 times 3. Don't forget all the numbers that were prime. X times x times x times y. So to find what's in common, I'm going to circle. I've got 1, 2, 3 2's in common. And I have 1, 2 x's in common. And only 1 y in common. I have things left over that were not in common with the previous term. So my GCF, when I multiply, will be 2 times 2 times 2, or 8, x times x, or x squared, and then y. So there's my GCF between 8x squared y and 24x cubed y, the largest amount that's in common between both terms. All right, method 2. Method 2, we just list all the factors of each term, and you find the largest factor that all terms have in common. So I'm going to start with numbers, comparing 18 to 27. So I'm going to start off with the smallest factors of 18, which is 1 times 18. The next one, I can divide 18 by 2, which is 2 times 9. Going up, I can divide by 3, 3 times 6. If I check the next one, 4 is not divisible by 18. 5 is not divisible by 18. 6 is divisible, but I already have 6 times 3. So once I've wrapped back up to the top of back to my list, I'm finished finding the factors. 27. 1 times 27. 2 is not divisible. 3 is divisible with 9. 4 is not divisible. 5, 6, 7, 8 is not divisible, wrapping back up to 9, which is 9 times 3. So here's all my factors for 27. Now the next step for this is find the largest factor that all terms have in common. So this time I'm going to say what's in common. They have a 1 in common, but it's not the largest number. They have a 3 in common, and they also have a factor of 9 in common. Once I find everything that they have in common, I just pick the largest value. So the GCF of 18 and 27 is 9. All right, the next one we're going to add some variables in. So I'm comparing 15x squared y squared, comparing it to 4xy squared. So I'm going to list off first my numbers with 15. 1 times 15, 3 times 5, and that's my entire list. I want to go ahead and break down my x squared as x times x, and my y squared as y times y. Moving on to my 4, I've got 1 times 4 and 2 times 2. X is my only x value, and I have y squared. Now looking at what's in common between these, we only have a 1 in common with the numbers. But we do have an x in common, and we do have 2 y's in common. So I have 1 x and 2 y's. So my GCF, the largest number in common is 1. I don't need to include 1 since it's just a coefficient. X is the largest amount of x's, and 2 of them is the largest amount of y's, so I'm going to write that as y squared. Now, we're going to break down and find GCF both ways on the back side. We'll do some with prime factorization, and we'll do some in our head with just finding the largest factor. Let's practice. So, how do you factor using the GCF? First, let's talk about what factoring actually is. If we're actually finding a factor, but the verb of factoring is sort of an unmultiplying. I don't like to call it dividing, even though that sounds like division. We are not dividing the problem, we're unmultiplying it. Or we can say we are undoing the distributive property. For example, the last chapter we did multiplication. If I gave you 2 times the quantity of x minus 3, you would multiply this or distribute the 2 to both terms and get 2x minus 6. Now, when we factor, we are finding the largest number that they have in common, and we are undoing the distributive property. So when I ask you to factor 2x minus 6, you say, okay, between 2x and negative 6, they both have a 2 in common. If I take a 2 out or unmultiply it, I have left on the first term x. And if I take a 2 out of negative 6, I have a negative 3. This is the process that we're going to do when we multiplied, and now we are going to factor by taking it the opposite way. For example, let's look at the first problem. 4x squared plus 6x. The first way we're going to do it is prime factorization. I'm going to take 4x squared to all of its prime numbers, which would be 2 times 2 times x times x. And if I take 6x to all of its prime numbers, I would have 2 times 3 times x. Now, just like we did on the front side, once I find those prime factorizations, I'm going to find what's in common to locate my GCF. So they have a 2 in common, and they have an x in common. So I'm going to write to the side here, my GCF for this problem is 2x. That's the piece we're going to factor out of our problem. And then I have to think about the distributive property backwards. 2x, and my first term used to be 4x squared. So if I factor a 2 out, I'm left with a 2. If I factor 1x out of this, I'm left with 1 more x. My second term, if I factor a 2 out of this, I'm left with a positive 3. And once again, I took the entire x out of the problem. Now you can also see, since we did the prime factorization, the 2 and the x that were not highlighted is what is left on the first term. And the 3 that is not highlighted is what is left on the second term. I have taken out the largest amounts from both terms and undistributed. this is now my solution. And you can check your work by re-multiplying. 2x times 2x is 4x squared. 2x times 3 is positive 6x. This multiplication needs to check back to the original problem. So that's using prime factorization. Number 2, 3x squared plus 12x minus 24. Pause the video and use prime factorization to find the factors of this problem. Okay, let's check our work. 3x squared is 3 times x times x. 12x is 3 times 4 times x. And this negative 24, 3 times 2 times 2 times 2. And really, this does have a negative 1 from that piece. Now, when I factored out, I noticed that they only had a 3 in common. So that's my GCF. Left over, I had 2 x's, or x squared, 4x, and a negative 1 times 8. So this is fully factored with GCF. All right, let's practice now without having to prime factor it. My next problem is 4x to the 5th minus 6x cubed plus 10x squared. If I'm not using prime factorization, I do have to think about the largest factor that they all have in common. So I'm going to look at my numbers first, and I'm going to list off to the side what my GCF is. Between 4, 6, and 10, the largest number that goes into all three of those evenly is 2. Now look at your variables. Between x to the 5th, x cubed, and x squared, they all at least have 2 x's in common. So x squared. I'm going to write out to the side here 2x squared. Since I did not prime factor, I can't see what's left over. However, we can use a division rule. 4 divided by 2 will leave 2 left over. And x to the 5th divided by x squared, using your division rules, will leave x cubed. Now recheck that. 2x squared times 2x cubed is 4x to the 5th power. My next problem, with the negative 6x cubed. So if I divide out 2x squared, I'm left with negative 3x. Negative 3 times 2 is negative 6. X squared times x is x cubed. And the last one, positive 10x squared. 10 divided by 2 is 5. X squared divided by x squared will completely take out my variables. Now, just double checking, nothing is left in common between 2, negative 3, and 5. I took out the largest number, and nothing is in common with the variables, x cubed, x, and none. X squared was the largest amount. So this is fully factored. All right, number 4. Our problem is negative 14x plus 21y. Looking at this problem, we have negative 14x plus 21y. I can see some numbers in common, but no variables in common. And we see a new problem here with this negative sign. Let's make ourselves a note. We're going to put here, if the leading coefficients is negative, the GCF must be negative. If the leading coefficient is negative, the GCF must be negative. So before we decide if the leading coefficient is negative or not, we do need to make sure this is in standard form. This is just x to the first and y to the first, and alphabetically, this is the leading coefficient. So since the leading coefficient for this problem is negative, I'm going to go ahead and factor out for my GCF a negative sign. Now, between 14 and 21, 7 is the largest number. And then they do not have any x's in common. So I'm going to factor out a negative 7, which will leave a positive 2x. And if I factor out a negative 7 from this positive 21, it now makes it negative 3y. You can check yourself when you get to these negative signs. Negative 7 times 2 is negative 14, and negative 7 times negative 3 is positive 21. The only reason we have to factor out the negative sign is because the leading coefficient is negative. You want this first term to be positive after you factor. So this is complete. Let's look at number 5. Number 5 is 4 minus 12x minus 8x squared. Glancing at this problem, you can probably see that they have a 4 in common, but we are not in standard form. Put a little star here. Must be in standard form. So in standard form, this is my highest degree. I have to take the entire coefficient with it. So negative 8x squared. The next highest is x to the first power, so negative 12x. And then my 4 is positive, will go on the end. Now, once it is in standard form, we see here the leading coefficient is negative. So not only do they have 4 in common, but I also have to factor out a negative 4. X squared, x, and nothing, no variables in common. So this is the only GCF. This will divide out to a positive 2x squared, a positive 3x, and because this was positive, but I'm factoring out a negative, this becomes negative 1. And you can multiply that back together to get the original problem. Okay, let's try another one. The problem is negative 12x squared y cubed plus 5y squared. Pause the video and try this one on your own. Okay, hopefully by now you found that neither 12 or 5 had any numbers in common. However, this is in standard form. This has degree 5 and this is only degree 2. That the leading coefficient was negative. So I started my GCF off with negative. They had no x's in common, but they did have at least y squared in common. So factoring out negative y squared, I'm left with 12x squared y minus 5. All right, so let's get some fractions in there. Number 7, 2/3 y to the 4th plus 1/3 y cubed minus 4/3 y squared. Looking at these numbers here, we notice they at least have 1/3 in common between 2/3, 1/3, and 4/3. So that's the first thing I'm going to factor out is a 1/3. Now with the variables, I have y to the 4th, y cubed, y squared. I at least have a y squared in common. Undistributing a 1/3. If I take a 1/3 out of 2/3, I'm left with 2. And you can check that by remultiplying. 1/3 times 2 would be 2/3. The first term had y to the 4th, so I have y squared left, plus, if I take out the 1/3, I'm just left with a 1, or a 1y. And this last one, negative 4/3 y squared. I'm going to factor out that 1/3, but it is still a negative sign, leaving a negative 4, and I took out my y squared. So that's it. And you can double check 1/3 times 2, 1/3 times 1, and 1/3 times 4, and then check the y values. All right, number 8. Let's write the problem down, and then I want you to practice this one on your own. 4x squared y squared plus 12x squared y minus 8y squared. Oops, I left off an x. Minus 8x y squared plus 4xy. So let me reread that again. 4x squared y squared plus 12x squared y minus 8xy squared plus 4xy. Pause the video and try this one out. Okay, between the numbers, they each had at least 4 in common. These were already in standard form. This had a highest degree right here of 4, 3, 3, and 2. The reason this 3 was in the correct order is because it had more x's than this one. So I factored a 4 out, and then I noticed I had x squared, x, x. So that's how I end up with my x there. Y squared y squared y. So I at least have one y in common. I found myself a mistake. Uh-oh. There is no 4 on this first term. Now, if you factor a 4 out, there is no 4. But if you factor out the xy, you are left with a 1xy. The next term, you're left with 3x minus 2y plus 1. Because the entire 4xy came out, you do need a placeholder of 1, especially if you were to remultiply this back. Now, if I were to remultiply this back and I would have checked this mistake that I made, I would have found my 4 times 4 does not equal 16 up here. So that's where I found my mistake. I was remultiplying them back and noticed that it was only 4 here. Therefore, I made a small mistake. But this 4xy times 1 does leave the placeholder for that 4xy. All right, our last concept in this. We have x times the quantity of x plus 1 minus 2 times the quantity of x plus 1. Your first instinct is to multiply or distribute, but this lesson is all about undoing the distributive property. So do not distribute into this. This here, we are trying to find common factors still. So the common factor between this first term and this second term is the whole factor of x plus 1. That's the first thing I'm going to do is factor it out. X plus 1. Now, after we factored out our GCF, we wrote in parentheses anything that was left over from the problem. So in parentheses, left over from the first term is just x. And left over from the second term is a minus 2. This is fully factored. Okay, let's try it out with number 10. The problem is 2w times y minus z plus x times y minus z. Same process. I have the same factor of this y minus z. So this I'm going to factor out first. The first term leaves behind a 2w. and the second term leaves behind a positive x. This is fully factored. Now, with two factors multiplied, the commutative property of multiplication also states I can put this as 2w plus x and y minus z. So keep that in mind. If I have two full factors of binomials, you can actually flip-flop the order of them because multiplication is commutative. Be ready to practice in class the next day. Thanks.